Drivability. That one word can get the attention of many service technicians. And when you couple drivability with the word problem, you can send shivers down their backs. But it wasn't always that way. ProTech presents Scan Tool Diagnosis. In this program on Scan Tool Diagnosis, we'll discuss the history of drivability, 1987 shop manual changes, scan tool capabilities and limitations, and scan tool usage. So let's begin the program by taking a brief look at the history of drivability. When emission controls were introduced in the early 1960s, most drivability problems could be corrected with a turn of this or a twist of that. As time wore on, many additional types of emission controls were needed, such as EFE, EGR, AIR, and PAIR, and the list kept growing. Drivability diagnosis was quickly becoming a black art, but help was on the way. In 1980, computer command control was introduced, and with it came the on-vehicle computer. Among other things, the computer had the capability of diagnosing trouble within the C3 system. This was made possible via the Assembly Line Diagnostic Link, or ALDL. The ALDL allowed the factory to run a complete check of the vehicle emission control system before it left the factory. Shortly thereafter, some electronics manufacturers thought service technicians could benefit from a tool like the type the factory used. The scan tools that developed were capable of reading the data that was available from the computer via the ALDL. In 1986, the shop manual recognized the diagnostic value of scan tools and included some scan tool steps in drivability trouble code charts. However, the number of scan tool steps were limited to the nature of the 1986 and earlier computer command control systems. But things have changed for 1987. For instance, the speed at which the computer can recognize problems in the system has increased over 5,000% in many applications. This allows the scan tool to recognize a problem, even if it only occurs for a split second. Also, General Motors asked the scan tool manufacturers to standardize the readouts of their scan tools. This allowed for standardization of the trouble code charts. It also reduced the number of steps in the charts. Now, since the trouble code charts have changed substantially, let's take a look at the 1987 shop manual changes. Due to the changes in the computer command control system and in the scan tools, the 1987 shop manual uses scan tool steps exclusively in many of the trouble code charts, so you'll need a scan tool to diagnose these trouble codes. Using a scan tool markedly reduces diagnostic time and improves your diagnostic accuracy. Now, before we use these trouble code charts, keep in mind the same engine in a different body style vehicle can have different equipment, and this can affect diagnosis. For instance, the 2.8-liter V6 engine used in Celebrity and Cavalier has electronic spark control as well as a map sensor, but the same engine used in the Camaro doesn't. Consequently, it doesn't have the same diagnostic steps in its trouble code charts, so be sure you're using the right shop manual. A scan data table is also new in the 1987 shop manuals. This information is meant to be used after completing a diagnostic circuit check and not finding any trouble codes. The specifications listed are used in conjunction with the scan tool readout. They give you a baseline with which to compare the status of various system components. If the readout of a particular component isn't within these specifications, chances are something is wrong with it and requires further checking or replacement. Section C1 in the shop manual can also aid in your testing because it provides you with information on the operation of many computer command control system components. In some instances, it also shows you how to test components. Now that you know what's changed in the 1987 shop manual diagnostics, let's take a look at scan tool capabilities and limitations. A variety of scan tools are available to aid you in your diagnosis, including the Tech 1, the Monitor 2000, Multi-Mini Scan, All Test and Auto Data, and others. Whichever scan tool you select, make sure that it can be used on 1987 Chevrolet vehicles. And when selecting scan tools, keep in mind that some scan tools have additional capabilities. For instance, some scan tools can be updated by simply plugging in a new software cartridge. This saves you the expense of buying an entirely new scan tool. And scan tools must be updated each year to work properly on newly released models. Also, some scan tools can be converted for use with other shop equipment, such as an engine scope or a remote display. And the Tech One scan tool has the capability of reading input to and output from body computers used on other General Motors vehicles. However, body computers are not used on any 1987 Chevrolets. In addition to their capabilities, scan tools also have their limitations. And these limitations vary between brands, so become familiar with the scan tool you're using by reading its instruction manual. Diagnostic use of the scan tool is also dependent on your knowledge of the computer command control system. You have to be able to interpret the scan tool displays properly, otherwise the scan tool will be worthless to you. And when you're using the scan tool, keep in mind that the vehicle diagnostic system recognizes when a scan tool is tapped into the system. And when the scan tool is connected, ignition timing and idle RPM change in some systems. These changes have to be taken into consideration during diagnosis. Now that you have some background on scan tools, let's move on to scan tool usage. Before we get into the actual hands-on demonstration of scan tools, you must keep in mind that this program is not intended to be an instructional manual for any particular scan tool. However, the fundamentals of tapping into the C4 system remain constant, and the shop manual diagnostic steps are the same for all scan tools. So, although each scan tool may operate differently, the results you get and the principles behind them are the same. With that in mind, let's start the program by using the Monitor 2000. Now, this scan tool is typical of the scan tools that are presently available and will help demonstrate their overall capabilities. We'll also use the Multi-Mini Scan at a later point in our diagnosis. To begin using the Monitor 2000, insert the software cartridge into the bottom of the tool. Make sure that it's installed correctly, otherwise the scan tool won't work. Now, flip to the diagnostic circuit check in the shop manual. Following the steps in the diagnostic circuit check is important, as it's the starting point for diagnosis of any drivability complaint. So, begin the diagnostic circuit check by turning the ignition on and then watching the service engine soon light. In our case, the light comes on and is steady, so the next step is to connect the scan tool to the system. With the software cartridge installed in the tool, insert the power plug into the cigarette lighter receptacle. The scan tool display should light up if it's getting adequate voltage. If it doesn't light up, make sure the connection at the cigarette lighter is good. If this isn't the problem, check the condition of the lighter fuse and make sure the battery voltage is at least 11 volts. Scan tools require a minimum voltage to operate correctly. You could also test the tool on another vehicle. When the scan tool is powered up, it will run a bulb check of sorts to ensure that all the LEDs and characters are working properly. Now connect the scan tool adapter to the ALDL and start the engine. Depending on the vehicle's diagnostic system, the service engine soon light may start flashing rapidly at this point. This is normal. The display will ask you to enter the model year of the vehicle you're testing. So enter the last digit of the vehicle's model year, then press enter. Now the scan tool will ask you what system the vehicle you're working on is equipped with. It's very important that you enter the right system into the tool. Otherwise, your test results will be worthless. If you're not sure which system is on the vehicle, note the 8th character of the VIN. Then look in the scan tool instruction manual. When you find your application on the list, it will give you a code to enter on the keypad. After you enter the number, the name of the fuel system you selected will scroll across the display. If the system you selected is incorrect, enter the right number on the keypad, then press enter. At this point, the Monitor 2000 will ask you if you want the displays in English or metric. Decide which display you want and punch the number on the keypad. The tool will automatically advance to the next question. Do you want a special diagnostic state? Since you want to check if any trouble codes are stored, and you need to get into a special diagnostic state to do this, punch in number 1 to answer yes. Again, the tool will automatically advance, and the special diagnostic states will scroll across the screen. For all vehicles except the Chevette, the diagnostic states of the Monitor 2000 include 6, field service mode, 7, backup fuel, 8, ALCL, and 9, road test. Since Mode 8 on this particular tool will allow you to check for stored trouble codes as well as check them directly, press number 8 on the keypad, then press Enter. Finally, the tool will ask you which mode you want to check. Remember, these modes are specific to the Monitor 2000 and do not relate to trouble code numbers. So to check a specific component or system, flip to the chart at the back of the tool instruction manual and find the component or system you want to check. Mode 3 will show us the PROM ID number as well as any stored trouble codes. So push number 3, then Enter. The display will show 3 sets of numbers: PROM ID, stored trouble codes, and mode selected. Each set of numbers will appear directly above the 3 color-coded bars. And keep in mind that the display will change according to the mode you select. If no trouble codes are stored, the word No will appear. If this happens, test the vehicle following the drivability symptom section in the shop manual. However, in this case, 2 trouble codes appear on the display, a code 13 and a code 63. So begin testing, starting with the lowest code number. As you turn to the code 13 diagnostic chart, you'll see the note Scan Diagnostics at the top of the page. This indicates that this particular diagnostic trouble code chart can only be used in conjunction with a scan tool. The diagnostic chart tells you to begin testing by warming the engine up to operating temperature. And there's a quick way you can check this with the scan tool. Turn to the mode chart in the instruction manual and find the number that represents coolant temperature. In this case, it's number 2. So push the mode button on the keypad once. This will cause the tool to erase the mode that you were in previously and ask you for a new mode number. Since you want mode number 2 to check the coolant temperature, press 2. Now the display will show you the coolant temperature. Since the temperature is over 80 degrees centigrade, run the engine above 1200 RPM for 2 minutes. At this point, the scan tool should indicate closed loop. But in this case, you only get open loop. So you move on to Step 2 in the diagnostic chart. Step 2 tells you to disconnect the wiring harness from the O2 sensor, then jumper circuit 412 of the harness to ground. The scan tool should display O2 sensor voltage below 200 millivolts with the engine running. Since you're still reading coolant temperature, you'll have to change modes. So push the mode button and enter the new mode number. Now the O2 sensor voltage will appear on the display, and it is below 200 millivolts. This indicates the circuit leading to the O2 sensor is good. So you follow the yes response on the chart, and you find the problem is caused by a faulty O2 sensor connection or sensor. On this vehicle, you find the connection to the sensor to be in good condition. So the code was set by a faulty O2 sensor. After replacing the sensor, clear the codes, confirm closed loop operation, and make sure no trouble codes are stored. Remember, you can check for trouble codes with the scan tool by pushing the mode button, then the number 3. Now the only code that remains to be checked is code 63. However, since the intent of this program is to expose you to scan tools and their uses, let's use a different scan tool this time. Let's try this microprocessor scan tool. After powering up the scan tool and selecting the model year and fuel system used, turn to the code 63 diagnostic chart in the shop manual. The first step in the chart asks you to correct the engine idle if it's rough, unstable, or incorrect. Our idle is fine. The next step asks if the scan tool displays a map voltage of 3.75 volts or higher. To check the map voltage, rotate the mode knob on the scan tool to the map VAC serif setting. Now the left side of the display will show the map value. In this case, it's over 3.75 volts, so we move down to the next step. Now turn the ignition off. Then disconnect the map sensor electrical connector and turn the ignition on. Now the scan tool should show a voltage reading of 1 volt or less. Since ours does, we'll probe circuit 455 with a test light for 12 volts. But when we check the circuit, our test light doesn't light. So referring back to the diagnostic chart, it tells us that there's an open in circuit 455. So the next step is to trace the circuit to find out where it's disconnected or broken. After you repair the circuit, remember to clear the codes, confirm closed loop operation, and check for any stored trouble codes. Since you're familiar with scan tools now, let's see how you can use them for detecting intermittent codes. For demonstration purposes, let's use our previous example of diagnosing a code 63. When checking the scan tool display in step 1, you find it's below 3.75 volts. So, following the chart to the next step, you find that code 63 is intermittent. Since the majority of intermittent codes are often caused by loose wires, have an assistant shake the wiring harness of the circuit you're testing with the scan tool. If the scan tool reading changes when the wires are moved, you've narrowed down the problem to the wiring. Now, if that isn't the problem, look at the diagnostic aids on the facing page. You'll find that an engine misfire or a low unstable idle that happened for only a short period of time may have set a code 63. Also, other test equipment, such as this data logger, is available to help you find intermittents. Basically, this equipment records ECM data while the vehicle is being driven. This recording is then played back while a scan tool reads the output. This can help you locate hard-to-find intermittents. So, in a nutshell, that's how you can use a scan tool and the diagnostic charts in the service manual to help you diagnose a drivability problem. In this program, we've covered the history of drivability, 1987 shop manual changes, scan tool capabilities and limitations, and scan tool usage. Whatever scan tool you plan to use, keep this in mind. Each brand of scan tool operates differently than the others, so be sure to become familiar with the scan tool you plan to use. These electronic marvels can help you diagnose a drivability problem faster and more accurately than you thought possible. But in the end, it's up to you. Your knowledge and skill, along with the shop manual and scan tool, can make those tough drivability problems a thing of the past.